All right, let's dive deep. And I mean literally, right beneath our feet, we're going to uncover a hidden vital sign in the soil that's completely changing how we understand the health of our planet. And believe it or not, it all comes down to a single critical number. How do you check a planet's pulse? I mean, it sounds like something out of a sci-fi movie, right? But what if I told you the answer isn't way up in the sky, but is actually right there, in the dirt under our shoes? Well, what if we could? That's the whole idea we're digging into today. Imagine we're on a diagnostic journey, kind of like soil doctors. We're learning to read a vital sign that tells us if the ground we depend on is thriving, if it's stressed out, or if it really needs our help. Okay, so let's get right to it. What is this hidden vital sign? It's a metric that scientists are getting more and more excited about because it gives us this super high-definition picture of what's really going on in the soil. It's called the MB to SOC ratio. And I know, that sounds super technical, but stick with me. The idea is actually pretty simple. All it does is measure how much of the total carbon in the soil is locked up inside living, breathing microbes at any given moment. It's basically a snapshot of the life within the soil. And here's why this is such a game changer. That community of microbes in the soil, they react to changes, things like new farming practices or shifts in the climate, way faster than the total amount of carbon in the soil does. This makes the ratio an incredibly sensitive early warning system. It's like a canary in the coal mine for soil health. To really wrap our heads around this, let's use a super simple analogy. I want you to imagine the soil is just a giant kitchen. This is going to help us break down the two parts of our ratio real easy. So, first up, we've got soil organic carbon, or SOC. Think of this as the kitchen's entire pantry. I'm talking everything. The fresh ingredients like fallen leaves, the leftovers from last season, and even those ancient dusty cans in the way back that have been there forever. It's the total supply of carbon. And then you've got Microbial Biomass Carbon, or MBC. This is your kitchen crew. These are the busy chefs, the bacteria, the fungi. They are the living, active part of the whole system, the ones taking all those ingredients from the pantry and cooking up new things. The carbon is literally inside their bodies. So let's put it all together. Simple, right? SOC is the entire pantry, all the food and storage. MBC is the size of your kitchen crew. The ratio between them basically tells you how efficient and active your kitchen is compared to how much food you've got stocked up. Okay, so we've got our vital sign. Now what? Well, like any good doctor, we gotta learn how to read the results. What do these numbers actually mean when we see them? It's kind of wild when you think about it. Across most of the world's topsoils, the amount of carbon held in that living kitchen crew, the microbes, is typically just 1 to 5% of the total carbon in the pantry. It's a tiny fraction, but as we'll see, it is an incredibly powerful one. Now, this part is absolutely crucial. A high number isn't automatically good, and a low one isn't automatically bad. It's all about context. See, a high ratio might mean your kitchen crew is working overtime, feasting on a ton of fresh ingredients. But a low ratio, that can mean two totally different things. Either you have a gigantic stable pantry, or your kitchen crew is stressed out, starving, and can't get any work done. And that's exactly why researchers were always saying, hey, there's no single magic number here. This vital sign is most powerful when you use it to track changes over time in a specific place, like a single farm field or forest. You're looking for the trend, not just one number from one day. So, if context is everything, what exactly is that context? To understand the trend, we have to diagnose the soil's whole lifestyle, if you will. What's affecting it day to day? First off, nature kind of sets the baseline, right? Climate's a huge one. Warm and wet conditions are perfect for a busy kitchen, so the ratio goes up. Different places, like a lush grassland, are naturally going to have a more active crew than a dry desert. And even the soil type itself matters. Heavy clay can lock carbon away where microbes can't get to it, which can lower the ratio. But the single biggest influence, the one factor that can totally change the game and change it fast, yeah, that's us. The choices we make and how we manage our land directly and rapidly impact this vital sign. Just take a look at this. The numbers don't lie. Simply switching from conventional tillage, plowing a field, to a no-till method can boost that microbial biomass, our kitchen crew, by a whopping 33%. Plowing is like setting off an earthquake in their world every year. No-till lets that community build a stable home and get to work. And it's not just about tillage. You see the pattern here, right? Practices that feed the soil, like adding compost or planting cover crops, they make the ratio go up. You're basically delivering fresh, gourmet ingredients to the kitchen crew. And on the flip side, things that beat up the soil, like intensive plowing or letting cattle overgraze, they cause that vital sign to drop. All right, so we've kind of diagnosed the situation. Now for the fun part, the prescription. How do we take all this knowledge and actually put it into action to build healthier, more resilient soils? This is where we're seeing this huge, and I mean huge, paradigm shift in how we think about soil. For decades, we mostly saw microbes as just decomposers, the cleanup crew that recycles dead stuff. But we now know they are the master builders. They are one of the primary engines for creating this stable, long-lasting carbon that makes soil so amazing. It's this incredible process called the microbial carbon pump. It's awesome. It works in basically 3 steps. Step 1. Microbes eat the simple, easy-to-digest carbon that plants release from their roots. Step 2, they turn that carbon into their own complex bodies. That's our MBC. And step 3, this is the magic step. When those microbes die, their dead bodies, this stuff called necromass, are super good at sticking to soil particles and locking that carbon away in a really stable form for a long, long time. And look, this is not some small side process. This research makes it crystal clear. The dead bodies of microbes are a dominant source of that stable organic matter that all healthy soil depends on. The takeaway? To build stable carbon in the soil, you first have to build a bigger, healthier kitchen crew. So why should you care? What's the bottom line here? Well, managing for a healthier MBC to SOC ratio isn't just some weird science experiment. It leads to some seriously powerful, real-world benefits. We're talking about better carbon sequestration, more of that carbon being stored securely for the long term, and soils that are just plain tougher and more resilient to stresses like drought or heat waves. Which kind of leaves us with this one big, fascinating question. By finally understanding and starting to nurture this invisible, microscopic world beneath our feet, could we be unlocking one of the most powerful, most scalable solutions to our planet's biggest challenges? It really does seem like the smallest things on Earth might just make the biggest difference of all.